This is going to be a test flight with the sole surviving plane. The other two broke. The wind is currently 2 miles per hour going west. 3, 2, 1, launch. And yeah, that one broke as well.
Where did it land? Oh, right here.
Right here. It went a whole 6 feet. And then the tail fin snapped off just like the rest.
So it actually breaks the balsa part. It's not like the pieces come apart. It's that the wood cracks itself.
Yeah, because balsa is pretty fragile.
And the other two, this happened to them just taking them out of the box because it was so fragile.
One of them broke out of the box, and the other one broke trying to do a test throw to see how far they even go in this wind. So yeah.
So this is not a user-friendly experiment.
No, it is not. I mean, these are the exact dimensions of my virtual glider that I made in the white box simulator. And these were laser cut. This wasn't just using like an X-Acto knife or anything. This was at precision milled, and it still cracked apart like a twig.
What was this experiment supposed to demonstrate?
This experiment was supposed to be determining what's the ideal dimensions of the wings and stabilizers to maximize flight distance. So in the simulator, this plane was able to fly from when launched at a 45-degree angle, it was able to fly for about 7.5 seconds before landing. This one didn't even fly for more than 2 seconds.
So this doesn't seem to be an appropriate plane model or structure to demonstrate this experiment for use
Not in real life, just in the simulator.
So what kind of changes could you make to this theoretically?
We would need much stronger wood, but this was calibrated for balsa. Like even the sanding is a factor in how well this performs in the simulator.
What do you conclude about this experiment?
That simulation does not always meet reality. No plane survives first contact.
Okay.
And I think that if I were to use a heavier, stronger wood, it would fly, but probably not even as far as these ones did, which is kind of underwhelming.
Why do you conclude that?
Because the main advantage of the balsa wood is it's so lightweight, there's almost no mass to be resisting the wind.
But the downside of using balsa is that it's too fragile.
Correct.
So,
and, yeah. It's like,
so the trick would be to find some magic point of lightweightness of wood, but strength of wood for durability.
Yeah. Or even, I don't know, do this out of plastic. Like if I were to, I don't know if I can 3D print from this file type, but yeah. I mean, the way that this thing is so thin, I almost want to use metal somehow.
Metal, and then that would add weight.
That would add weight, but it'd be basically indestructible for these kinds of forces.
So what about the idea of 3D printing a plane?
Well, the problem is that these are so thin that if I 3D printed it, it would probably snap just removing it from the build plate. Like it's...
that's in your experience, that's the case with thin built things.
Yeah, with thin plastic, if it's really wide and flat and you peel it off at the wrong angle or the wrong amount of force, it will crack before it's even done being removed.
About how long would it take to 3D print an airplane of this size?
Let's see, the wingspan is exactly 300 millimeters, which would mean that I don't even think it would fit on my 12-inch 3D printer.
Can you do it
diagonally?
Can you do a smaller model?
I could scale this down, maybe. It's also a question of file type, because this was the download from Whitebox was made for laser cutters, not 3D printers.
Well, so it's sounding like the 3D proposal is the most viable so far.
It's the most viable, but it would involve a lot of file conversions that may not work.
Okay, so this is an assignment that you want to submit for tonight. Do you want to try to extending it with a 3D, just a proof of concept or disproof of concept with 3D print?
I don't know if it's going to be done by tonight. Even if I shrink it down, it might still be, I don't know.
Well, let's give it a try and maybe do like a follow-up to this experiment.
Okay.
All right, thank you.
Thank you, and recording.